So, bringing up first, we have Dr. Valerie Schneider, and she's currently the Deputy Director of Sequence Offerings and the Interim Head of Sequence Delivery Program at NCBI. She also manages NCBI's involvement in the Genome Reference Consortium. So, Valerie, if you can take it away.
All right, thanks, Daniela. Hopefully you can hear me. And if we could advance to the slides. All right. So, next slide, please. I'd like to just begin today by acknowledging that there are many talented people at NCBI who manage data in all sorts of forms, as well as all the support that we get at NCBI for the work that we do. So next, please. Today, I'm going to tell you who we are at NCBI, introduce the types of metrics that we use, and also tell you about 3 different stories of metrics-based resource management. So next, please. NCBI was signed into law in 1988 as part of the Health Omnibus Extension Act. And as you can see on this slide here, our mission is to develop new information technologies to aid in the understanding of fundamental molecular and genetic processes that control health and disease. Next slide. So today, NCBI has one of the highest access U.S. Government websites, as shown here on analytics.gov. You can see it tops such perennial favorites, such as visits to the Postal Service or the IRS. But it's really a metric that's like this that makes it really obvious and imperative that NCBI gather its own metrics on our repositories and the data they contain in order to best manage them and ensure that we're delivering meaningful and valuable content to our users. Next, please. We're organized into 3 branches, as shown here, and today I'm going to be talking about the repositories of the Information Engineering branch, which is led by Kim Pruitt, who you'll be hearing from at the end of the workshop today. Next slide. The Information Engineering branch has 15 different offerings, which are groupings of products that have related goals or features. And these products or offerings have impacts on research, policy, public health, and patient care. And today I'm going to be highlighting 3 of these, PubMed, Geo, and dbGaP, which house very different types of data that range from literature all the way to phenotype. So next slide. So regardless of the specific offering or data type, I'll point out that data flows through NCBI largely through the stages that are shown on the slide here. And at all stages, we've got a combination of automated and manual processes that work together to deliver content in a whole bunch of different forms, be it web, FTP, or even documents. And so metrics can be gathered for each of these that ultimately enable us to gauge the usage and the utility of this data, which in turn tells us about the health of our repositories, plan for their future, and also make sure that we're meeting our mission. Next, please. So the first type of metrics that I want to mention are those that are associated with monitoring our website performance and errors. And these metrics really tell us about the health of our site and help ensure that we meet our service level objectives. On the left, you can see this world map of web page load times for a particular NCBI offering. And on the right, we're looking at the uptime of this resource over a 1-month period. It's up more than 99.9% of the time, but as you can see with these little red lines here, downtime, meaning that a user gets an error message when they try to hit a page, does occur. But you can also see that it tends to be particularly punctuated and short in NCBI, and it's typically due to just some kind of network blip. But because our metrics show us that it does happen, it's also enabled us to put into place mechanisms that further reduce the impact to users, such as creating automated alerts for developers when the downtime hits a particular threshold, so that we have a speedy response. So some of the other performance characteristics and errors for which we gather metrics include the latency, which is really the network lookup time, client errors, and server errors. So next, please. The other type of metrics that NCBI gathers are related to the usage of and the user engagement with our offerings. And these fall into the 4 broad categories that I've listed here, and I've just shown on here some of the very specific metrics that we capture. And I've called out the customer feedback category to just draw attention to the fact that the data that we gather here are really much more of a mix of objective and subjective measures in contrast to these other 3 categories that are really objective measures. And so while the Net Promoter Score, which I'll talk about in more detail shortly, can be considered objective, the rest of these feedbacks are typically subjective or qualitative and require additional effort in their interpretation. So for that reason, we put a lot of emphasis on these objective measures in the first three categories, which reveal to us what people are actually doing with the data as opposed to what they might just be saying about them. So next, please. So to manage and make use of all these different metrics, NCBI has created a number of different dashboards, and these dashboards help us gain a holistic picture of the usage of our repositories. So here we're looking at a dashboard for one offering, and you can see metrics from three of those categories I mentioned before. So next, you can see basic user behavior through page views. Next, please. Characteristics of the visit by the referrer that got them to us. And next, please. The new versus returning users tells us a little bit about our users' own characteristics. So next, please. So I'm now going to move on and tell you about some specific ways in which NCBI uses the metrics we gather to improve the usage and usability of our offerings. And the first story is going to be about PubMed. So many of you may be familiar with PubMed, which is a citation resource that's used by more than 53 million people each month. It's also the first offering that we are rebuilding in a cloud environment to make sure that it really remains reliable as we head into the future. And as we've been making this migration, we've been using metrics to help us improve the resource. So next, please. So to get started, we looked at customer feedback as measured by the Net Promoter Score, which I mentioned earlier. And we captured this in a survey that we ran on our legacy PubMed product. And as you can see here, Net Promoter Score is just a measure of how willing users are to recommend your website or your product to others. So next, the values of a Net Promoter Score can range from -100 to 100. And next, please. With an NPS score of 62, we can see that PubMed looks pretty good in comparison to several other types of websites that you might be familiar with. But we recognize that there's also still room for improvement. So, where should that improvement be targeted? And we asked whether other metrics could help us make that decision. So next. So we decided to dig a little bit deeper into the usage of the two PubMed platforms, which are the desktop and the mobile platform. And this graph here plots the number of users on each platform over time, with desktop in blue and mobile in red. And as highlighted by this yellow arrow here, you can see that over the holidays, the desktop usage drops quite a bit, but the mobile usage remains a bit more constant. And that's probably because people are still carrying their phones around with them even when they're not sitting in their offices. But this discrepancy between the desktop and the mobile usage patterns then spurred us to look even more closely at that Net Promoter Score, since the different patterns might mean that users also have different expectations for the platform. So it's really important to dig down into the metrics that you gather. So next, please. So as you can see here, what we found was a large discrepancy in people's opinion in PubMed between the two different platforms. And this helped tell us that the mobile site might be the part of PubMed that could reap the most benefit from improvement as we made this move to the cloud. So next slide, please. Furthermore, we went ahead and analyzed metrics such as click and tapping engagements, and it showed us that one particular area of the mobile site that might really be worked on was in the area of search. So as you can see here, while about 37% of visits on the desktop platform involve site search, that number was only 8% for the mobile users. But next, please. If we looked at what people on the mobile site were clicking on, we found that actually 10% of them were launching the desktop version of PubMed on their mobile device. Next, please. And when they were then running the desktop version on their mobile, 20% of the time they were running a search. So this is telling us that it's not that people on their phones don't like to do search, but the experience needed to be improved. And so this was an area that was ripe for improvement. And so on the next slide here, I'm just kind of showing you the legacy and new pages where on On our landing page, we put more emphasis on getting access to the advanced search. And next, please. You can see that the interface is really quite engaging for search. And then next, we also updated the features on our actual search results pages with an emphasis on filtering. Next, which helps people really narrow in on the articles that they want. So this updated version of PubMed is now available, and it's soon going to become the default experience for anyone using their mobile device. So next, please. I'm going to tell you a really brief story now about GEO. So next. So in contrast to the literature that's in PubMed, the GEO database stores gene expression and epigenomics data sets. And there's more than 100,000 people who download over 1 terabyte of data from that resource each month. Next. So while GEO holds a lot of data, it's really critical to know whether that data is meaningful and valuable to the community. So are we making an impact? Next. So one way we can evaluate that is through third-party citations. And we've already heard a lot about the benefits and the perils of looking at citations. So this is something that we consider, and we're still learning a lot about how to use. But these third-party citations are publications that cite data that was authored or submitted. The publications were authored by someone who wasn't the data submitter, and so they're indicative of usage of the data. And so from that, we infer value. So sort of in addition to serving as a lagging indicator of the data value, these sorts of metrics can inform our curation activities and new development. And while we're not yet capturing these citations in an automated fashion, given that they are really important for helping us understand the usage, it's an area where we plan to invest time in automating and standardizing. Next, please. So lastly, I'm going to tell you about how metrics inform our management of a third offering, which is dbGaP. And really, in order to be able to assess data utility, the data has to get to the public. And that means that we need metrics through all points in the life cycle of a data repository. So metrics that measure against pre-release processes enable us to evaluate progress against goals and can inspire action on our end. So next. As described on this slide, dbGaP is a controlled access database that stores human genotype and associated phenotype data. Users gain access by requesting approval from an NIH committee. And I'll point out that dbGaP receives really large and complex data submissions that require a lot of QC. And so the more issues that can be caught on their initial review by our curators reduces the amount of time that's spent in sort of back and forth with the submitters and speeds the time of that data getting out to the public. So next, please. So the main goal of the dbGaP submission pipeline is to release QC data to its user base in a timely fashion. And so here we're looking at the backlog, which is the green line running along the top, which serves as a lagging metric for the dbGaP submission curation process. And it's also a lagging indicator for the volume of user submissions, which are shown here in orange. And so process initiatives that we have going on at NCBI that are associated with the backlog can be evaluated to assess their impact on the progress towards this goal that we have. And so with this slide, we're going to look at a couple of examples of that. So next, please. So in late 2018, there was a short-focused all-hands curation sprint that was done in anticipation of a slowdown in processing because of a curator retirement and the time that curators were now going to have to take training the new hires. And so the red lines here show the actual retirement and training or hire events, and the block is the training period. What I want you to notice is in that area where the all-hands processing occurred, there was a dip in the backlog in the green line. And then there was an increase in the backlog as the staff output slowed during early training, and then the backlog starts to drop off again towards the end of each curator's training period as they gain proficiency. Next, please. But we can look at the impact of these changes on the curation process, on the goal of faster data release. And so it's shown here for fiscal year quarter 3 in both 2018. Both the average and median times to the data release were reduced substantially, indicating that ultimately the addition of the new staff had a positive effect. I'll point out that, as you can see with the average and the median, that it's important to look at multiple measures because outliers can really skew your interpretation of the data. Next, please. We're continuing to review the backlog and the release times with lagging indicators as we start to automate new steps of our pipeline. And these data are going to be very valuable to us, particularly with respect to helping stabilize the variability that we still see in the release times, even though the numbers have dropped substantially with time. Next. So I just want to end my talk by making a brief mention of another dbGaP metric, which is dataset usage. And this graph here is plotting the total number of access requests and downloads for each dbGaP study. And so while older studies have had more time to accrue access requests and downloads than the newer ones, you can clearly see exceptions to this trend, such as some of the studies I've highlighted here. And although it's not shown in this graph, we've also seen examples where there are studies that remain highly used for much longer periods of time than the typical study, which exhibits a peak of use right at the time of publication and then drops off. So not only are these usage metrics meaningful to NCBI as we develop our repositories, but they're also valuable to the funding agencies that support this research and also to the users of this data. And so this is another area where we're looking to do more automation of metric gathering and analysis. And lastly, I'll just note that historically it's been challenging to access dbGaP due to a bottleneck of moving really large data sets around. But this bottleneck should no longer be the case because with the move to the cloud as part of the NIH STRIDES initiative, it's going to be a lot easier to deal with large data sets. And these approval and download metrics now actually inform our plans for how we store data sets in the cloud, such as hot versus cold store, which have different fee and access structures. So as we move to the cloud, it's clear that we're going to have a whole new set of metrics from which we can learn and profit. So next, please. So with that, I'll just wrap up and tell you, today I told you a little bit about NCBI, the various types of metrics that we rely on for our repository and how we use them within the repository to manage our own processes. And thanks very much.